All right, so let's talk about Angular. So Angular is one of several MVC JavaScript libraries that have become very popular of late. But there's quite a few of them that more or less follow the same ideas, and they became important once browser programming became more and more relevant, right? As we asked more features from our web applications, the more JavaScript became important. Most web applications used to be, a lot of server-side programming, right? Where ASPs and PHP and Rails and Python and it's still today. A lot of the dynamic web applications use these server-side technologies. But more and more, we see that these JavaScript solutions that run on the browser are becoming more and more prevalent, just because they provide a much richer experience from the user's point of view. So today I'd like to talk about Angular. Let's create a brand new project. If you want to follow the documentation, certainly the best place to go is to the owner and see what they have to say. Google's has a team of folks working on this day in and day out, and they're very good at responding to questions and documenting, and they often give a lot of talks also locally. So I welcome you to certainly read the documentation from the authors. So let's create a new application here, just an intro app, this will create an empty project, right, with just a single top level component. Angular has fully jumped into the modular component design philosophy, where presumably all these are reusable, self-contained, and pieces of artifacts that can then be reused to build something much more complex. Components became popular, in the perhaps at the turn of the century, although they've been around for quite a while, but never to the importance and level that they're in today. But the idea of components is we're trying to copy some ideas from other industries, such as the electronics and electrical folks that have been around. Those industries have been around for forever. Well, the electricity for a couple hundred years, and they have a lot of standards that they've been able to design over the years, where they have been able to standardize certain ways to transmit electricity, to consume electricity, and also the electronics industry also has a lot of good practices on how to modularize things, how to reuse things, how to create interfaces with modules that are able to connect to one another, and they fully document all these interfaces. You have the chips that this big book of chips that electronic circuits that allow you to see exactly what the interfaces are for these black little boxes that you can then connect together and build even more complex systems, and all the way up to having communication buses that allow multiple electronic appliances to just connect and talk to one another. As long as you maintain a particular interface that you play nice, with the various connectors, you can talk to many different devices on the same bus, right? So we're looking in the software industry. We're looking for something similar, right? Where we could design code that is modular, self-contained, has very well-defined interfaces that we just drop in an interface in an infrastructure, and it just works, right? That's the intent. Several vendors have attempted this, and they have their own version of component technology. .NET is a prominent one. J2EE is another prominent one, right? That if you write your code based on certain standards, right, following certain interfaces, you can just take your little nugget of software and it just works inside of a framework. You write a Java JSP or servlet or a bean and you drop it in a J2EE VM, and it automatically is multi-threaded. It's automatically is secured. So it automatically it can be stored into a database and reconstructed from the database. It just plays nice with the rest of the environment, without the developer having to code any of that. Okay, so all these great ideas that have been around in the server side for quite a while, we are starting to see that we are reusing a lot of those same ideas on the client side. The reason we even invented these ideas of object orientation and component technology is to deal with complexity. As we create even more complex software artifacts, we need that capability of dealing with the complexity of large projects. JavaScript didn't have that problem, since JavaScript was for small things, validating things here, animations over there, simple things. But as Google and Facebook and Netflix and all these large corporations started, betting all their future on the web, right? They say, well, our entire infrastructure, right, our entire user interface and the way our applications are going to run on the web. So we need much more sophisticated infrastructure on the client side, on the browser side. Yes, and again, many vendors have had their take on what should that look like, and again, building on things that we know work, borrowing from J2EE, borrowing from .NET, borrowing from a lot of these other infrastructures. We have now full-blown languages that are fairly sophisticated, with full-blown inheritance and modularization and interfaces, implementing interfaces and public and private and all sorts of validation of data types, with TypeScript now, and inversion of control. So we have a full-blown real development environment that rivals or starts to rival any of these more mature infrastructures on the server side. Anyway, so that's the spiel on why Angular, or why any of these infrastructures, right? All these infrastructures try to deal with the complexity and good software engineering. Anyway, so we created an app. Let's open it up with WebStorm. Let's see. I believe I might have created under NEU and webdev and intro. Here's my intro app. I'll open it up. And in here, we have, first of all, there's quite a few pieces here. A lot of them have to do with the infrastructure of being able to compile and convert the high-level language of TypeScript into its low-level implementation under JavaScript. Again, as I mentioned earlier, now everything is components. So let's see if we can start this. We can do ng serve, open. ng for Angular, of course, but we went over that already, right? So here's our dummy Hello World application, Angular application. All right. Okay, so let's see if we can start building something. I created a couple of slides here that I'm going to make available also on the on Blackboard to follow along. Being able to create new applications, ng new, ng serve, and whatnot, which is basically what we did. In particular, I wanted to introduce routing. So normally, the application that you've been working on for the last couple of weeks, for routing, you've been using just the regular navigation, right? You have a hyperlink, you click on it, and you navigate away from that page onto some other page, right? And that's a classical way of implementing, navigation on a website. But Angular is a single-page application, right? We've been mentioning this for quite a while. In that we're only going to ever load one single page, the index page, and we're never actually going to deliberately leave this page. Right? Everything is going to be injected. Any content is going to be dynamically injected. So I'd like to introduce to you routing. How are we going to do navigation in a single page application? All right. So first of all, the content that we're looking at right now, the default content is welcome to app is right here, this index page, and what it's doing, it's rendering this app root. Okay, notice that if we open this and look at the source code, if we look at the source of the page, nowhere do we see that image. Right? Nowhere do we see any of that text. Okay, the only thing that we ever see is this app root. That's all we see. Right? This content, this image over here, this welcome app, all these hyperlinks, they're not actually in the source of the page. They have been dynamically injected in there. Right? Instead, we have a placeholder. There it is, app root. Okay, that somebody is injecting content in there programmatically. Right? There's some magic happening. I just want to walk you through that magic. So the app is implemented here under the app directory. In here we have the module, the app module. Okay, this is also referred to as the top level module. We're going to be creating several modules, right? That you can think of them as packages, Java packages, or C# packages, right? Where you can have several classes or components in a package that can then be exported to be reused by other packages, right? So this would be the top level package, right? And it's loading some of the low level components that it needs. One of them is the browser module. So Angular went a little further and said, well, I don't want Angular just only to be used for web development, right? Not necessarily just only the browser. Many of these infrastructures are finding a home outside of the browser, right? I want this to be able to run maybe natively on my desktop, or natively on my phone, or natively on a TV box, right? So a lot of these infrastructures, React Native and Angular Native, they are looking to differentiate or be able to abstract, right? Who's going to render this, right? So this is one particular way of rendering it on the browser, but certainly this could be rendered also on a desktop, right? On its own native window, or native on a phone. But this is their attempt at doing that, right? Or breaking out those two things, right? So because we're rendering to the browser, they inject here, or they load the browser module, and that's what we're going to be rendering to. All this happens automatically. You don't have to do anything to do this. It loads the top level component, okay, the parent component, that loads the top level templates. The top level template that has exactly the same name, app component.html. And this is the content. This is the content that actually gets rendered. Right? This is what gets injected into our content. This is where you have the hyperlinks, the hello world and whatnot. Okay, And we're going to be building our own components, right? That have it'll have a JavaScript portion, well, a TypeScript portion of it. This is the top level component that is loading the top level templates. Okay, and it's passing some data back to its template. So the template and the components, they are tied to one another, and they're tied by using this decorator. Again, this is another idea copied from .NET, from Java, right, where you can decorate your source code, right? You can something that would normally just be a class, something that would just be a class, that would be a container of attributes, now it becomes something more than just a plain old class. Right? We are decorating it, telling it that this is a component, right? Meaning that this class, right, is going to play a part in a larger infrastructure, right? That somewhere outside, bigger than us, somebody's going to read this and interpret this. Okay, it's like, I wrote a Java bean, or I wrote a component in .NET, right? And because it's a .NET component or a Java or J2E component, when I instantiate it inside of a JVM, inside of a J2E web application, it all automatically is multi-threaded. It's automatically secure. It's automatically can be saved to a database and whatnot. So same thing here. Because we decorate this as a component, this is going to have a special meaning. And it's meant to be instantiated once, and is going to be tied to an HTML that we configure. We say that the HTML that goes along with this class is so-and-so. It's app.component.html. Right? And now they're tied to one another. They can talk to one another. If I declare a variable in my class and I give it some value, it will be available on the template side with that same name. Right? There will be a binding between these two places, right? So that if I visit that HTML and I reference that title, it will be injected, right? It will be replaced with the value app. Right? So if I navigate to component.html, we'll see that it's this welcome to title. You see that? Welcome to title, that's where we get the welcome to app somewhere. Oh, there it is. Welcome to app. Right, so that's actually dynamically rendered, that app over there. Okay. Anyway, let's actually create our own from scratch. Right. So let's not try to understand somebody else's components. I'm going to blow away the template. I'm just going to say hello. Okay. It's also while the ng serve is running, it's listening for any changes in my file system, recompiles everything, and it's hooked up to the browser to tell the browser to reload. Right. It recompiles everything and it reloads automatically. All right. So let's get a go on the assignment. All right, let's start playing around and build what we need to build for the assignment due next week. Right. So let's create a directory where we can play around with the assignment. Right. Well, we'll do that next.